Today's discussion will be presented in 3 sections since we are recording this session for a radio broadcast on Federal News Radio 1500 AM. Feel free to post questions and comments during the session, and we'll try to get them answered online. We are pleased to welcome our moderator, Tom Temin, the host of Federal Drive on Federal News Radio 1500 AM and federalnewsradio.com. Let me turn over the reins to Tom to begin today's discussion.
Welcome and thanks for joining us. Our guests today are Charlie Bradley, the Technical Director for NSA's Technology Directorate, Dave Michalczyk, he's Chief Technology Officer at the Defense Information Systems Agency, Dr. Naveen Vembar, he's Cloud Engineer and Director of the GSA IT Integrated Award Environment, Nathan Jones is Vice President of Federal for Red Hat, and Tracy Pavillard, Executive Director for Dell Federal. Great to have you on the panel today. And the wonderful thing about cloud computing and cloud in the federal government is it is like the gift that keeps giving. There's always something new to learn about it, and there's always some new development in the technology area, and so we're going to explore some of those today. And the basis of the topic today concerns, in some degree, operating systems, which early in the cloud era people didn't talk about as much, but it turns out the software in a cloud is as important as the hardware in a cloud. And so I wanted to start by asking first the government people the options for cloud operating systems you're looking at. How do you evaluate what it is that's on the very first thing on top of the so-called bare metal? Charlie, why don't we start with you?
Sure. For us, cloud means a lot of different things, and I think that'll come out in some of the conversations today too. But our implementation, we're very mission-driven. So the determination as to operating systems, kind of primarily driven by mission, but also driven by economics. So for us, going down an open source path was kind of a first option to consider. We've invested pretty heavily in OpenStack as one of the operating systems. You know, we're by no means reliant on one operating system for everything that's going on because there's different components within the cloud.
So the OpenStack resides where in the whole chain of events between the operator, the user's desktop, and the cloud baseline hard drives?
So the easiest, I think, to explain is in the context of infrastructure as a service. If you think about utility computing, for us, OpenStack is kind of that foundational element.
And so it supports a lot of the applications that you're running and virtual machines and so forth that might be running in that cloud? It
supports that virtualization environment that allows applications to be written on top of it.
Okay, and Naveen Vembar, you are in charge of something that a cloud application for GSA, a pretty broadly based one. Tell us what your choice process is and how OpenStack and open source relates to that whole question.
Absolutely. Since we had the luxury of being a green field, we actually built out using open source from the beginning, rather than having to lift and shift anything, you know, from our legacy environments into this into an OpenStack. So rather, not an OpenStack, right? And you know, in the other cases within the GSA, as we're talking about legacy systems, though, sometimes we'll have to make the choice. Okay, we have to take an existing environment, a proprietary stack, and figure out does it move to the cloud, and you know, go with that as sort of a bimodal IT kind of approach to transitioning out of hardware. But one of the biggest things that we're trying to do and actually pushing across the board at the GSA is not only do we have the OpenStack at the operating system level, but we're actually pursuing containerization strategies as well. So we can drive us away from saying, here's a monolithic application and we're going to build that monolithic application again in the cloud, and instead go to microservices and smaller components that we can deploy out into the world and move them around more transparently to the baseline application that's sitting on the IaaS.
So tell me a little bit more about containerization.
Sure.
That's a word you typically hear in the mobility field for the devices. What does it mean in the cloud context?
Absolutely. So there's a lot of work around. There's a whole group of folks who are getting together under the title of open containers, right? They're building this open container standard. And what containerization
sounds like Tupperware.
It does, but it actually, actually in somewhat it is, right? Because it is a way to isolate away little pieces of functionality. So a single API implementation, a single web server, and really make that a tightly controlled, deployed singular capability that has nothing in it except that.
And what is the value in doing that?
So multiple values. One, you can isolate away these different points of concern, right? So actually, it's a little easier to secure. You can share them. They are inherently open source. They become infrastructure as code. So I can hand that out to anybody who needs it. I can also, move them, right? So if I have an IaaS provider that I decide isn't performing, I can move the containers as they are to another IaaS provider and make that an easier transition process and transparent to the actual end user of the application in the end.
All right, so it's almost like the object idea
Exactly.
in a way.
Exactly. It's taking virtualization to that next step, right?
Okay, and Dave Michalczyk, of course, DISA is at the center of everything cloud in the government, at least in DoD, but in many ways driving standards throughout the government. And so what is the thought process for the many, many types of things that DISA hosts for cloud?
So it really depends on what problem we or you are trying to solve. In the Department of Defense, we do have a policy that says open source is considered on the same level playing field as proprietary software. So we constantly go through this decision process to build rather than buy. And I can give you two examples where we've gone, one where we've gone proprietary and one where we've gone open source. So a few years ago, we were trying to turn up our first infrastructure as a service cloud. It's subsequently been called MilCloud. It's fully operational at unclassified and classified levels. And at the time, the most expeditious way to do that was to use existing licenses for a proprietary software product, VMware, and essentially just put additional management capabilities so that we could automate the provision of virtual data centers based on that existing VMware technology that we already had licenses for, already existed in our infrastructure, and perhaps most importantly, our customers were very comfortable with. They have grown up their applications on a stack of essentially VMware hypervisors and then either primarily Windows or Linux running on top of that. So that was a natural fit. Now, moving forward, we are looking at MilCloud 2.0. We have an analysis of alternatives going on right now, and we may be looking at an acquisition to replace the current infrastructure. And I do encourage everyone to take a look at disa.mil, our website. We're going to have a forecast industry on November 2nd. Sadly, it's already full at the in-person presentation. They'll be taking place at the Reagan Center, but you can sign up and view those presentations via streaming content. So that was a buy decision. A build decision, though, or an open source approach, if you will, we took in another cloud problem we were trying to solve. So we wanted to use big data to solve cybersecurity problems. How do we take all of this data from our cybersecurity sensors, our performance monitoring systems on both our unclassified nets and our classified nets, correlate that together and make better decisions about what adversaries are trying to do to us and what we can do to prevent those adversaries from doing that to us. So we actually adopted open source technology that was originally pioneered by the National Security Agency. They had taken Hadoop and basically built a big data platform on top of it. It had been piloted in this cyber use case with United States Pacific Command, and we essentially adopted that. And now that big data platform is not only forms the basis of DISA's Cyber Situational Awareness Analytic Cloud, but it's also being used by the Army and the Air Force for them to build cyber analytics on top. So once again, it's not a hard and fast decision. We view open source and proprietary software as on an equal playing field, and we pick the right application for the right job.
Okay, and I wanted to ask Nathan Jones of Red Hat. That must be a question that comes up a lot. And what is the relationship to OpenStack if someone has, say, 10,000 VMware licenses and they're running all these virtual applications? How does that all relate, and what is the value proposition for the OpenStack in those typical kinds of virtualized environments?
So I think when we look at the operating system layer, it's probably best to think of it in bimodal terms. And if you look at the traditional Mode 1 architectures and applications, customers are looking for consistency when they move to the cloud. So you see customers looking at basically Red Hat Enterprise Linux and Microsoft as their destination operating system environments. And I think that's because of efficiencies. They want to know that the tools they've built, the processes, the security processes, everything works the same in a cloud environment as it would in their bare metal or virtualized environments. And that goes for traditional virtualization architectures as well. If you look at the way my colleagues here answered the question in terms of the Mode 2, more cloud-ready application environments where customers are going to need better tools for modularity, better tools for container management, better tools for horizontally scaling, then you look at OpenStack being that evolution of the operating environment for the cloud. So it takes the operating system and goes to a whole new layer. It takes virtualization and goes to a whole new layer. And what we see there is customers adopting OpenStack as a standard for their private clouds to get the same kinds of functionality and capability that they get in the public cloud. So I think that you got to think of that operating system question, and we probably think of it more than others here at Red Hat, but in two different ways in terms of what customers are doing for most of their applications that are just moving to the cloud but are traditional apps, and then separately look at those applications that they've built in a new way to take advantage of these new capabilities. And there, definitely OpenStack is the answer to that question.
So the implication of all of this is that in moving to the cloud, you're not simply replacing the data center on premise with something you're paying for by the month, but you're fundamentally re-architecting a lot of your IT.
Well, that's the opportunity, right? I mean, I think you see a lot of folks who have just moved things to the cloud, and literally they want consistency there. So it's a very standard, they want to know that that operating system is going to work the same way, the drivers, everything's going to work the same as they expected in the private data center. But customers who are pushing the envelope, and several of those are here with me on the panel, they're looking at how do I get even more out of this architecture, and that's where you see them leveraging all those additional capabilities that come with OpenStack and developing new processes and tools to move to using OpenStack in a private cloud environment.
I would actually add to that, right? That's 100% correct. You know, I think a mistake to make, right, is just to recreate your hardware in the cloud, you know, and just say, hey, okay, it's just somebody else's hardware now, right? The real thing that you want to do is say, okay, so where can I make my processes change? Where can I gain cost efficiencies by not actually having, you know, the same amount of hardware running, you know, in September as compared to January because, you know, the traffic's down, or even better, way better, you know, Wednesday at 2 p.m. versus, you know, Saturday at 12 a.m., right? Those are very different times of day. So why are we running the same level of hardware, the same scope of hardware when we should be, you know, contracting and expanding as necessary? And then on top of that, right, the next step is really moving to that DevOps world and saying, I've got infrastructure as code. I can recreate that as I need, you know, where I need it. I can expand it as I need it. And I can also, to the customer's benefit, right, build applications more rapidly because I have everything in that stack is now code, right? Everything from the infrastructure upward is code.
Okay, good point. And I wanted to get to Tracy Pavillard from Dell Federal. You have a view across many agencies from a vendor that for many, many years has been all over the federal government. What do you see, what are the trends you're seeing in terms of how people are approaching cloud now as we approach fiscal 2016 pretty soon?
Well, thank you, Tom. I think, you know, I think the four panelists that have already spoken have shown that there's, you know, a very, very broad implementation of a number of different technologies. The beautiful thing from a Dell perspective is we've grown up as an open standards infrastructure company. So we don't have any legacy proprietary stacks to protect like many of the IT infrastructure providers do. So from our perspective, it doesn't really make a difference to us which operating system, and I'll be nice to my friends at Red Hat since, you know, we really do have a great partnership with our friends at Red Hat, but it's, and we've done some fairly unique things with them, but from a Dell perspective, it doesn't really matter whether somebody's running VMware or OpenStack or Red Hat Enterprise License. Our infrastructure is built to provide support for any and all of those, and I think you'll never see us go down a proprietary path. We're going to continue to be an open standards company, whether we're talking about compute or networking or storage, whatever it may be.
Yeah, and Dave from DISA, you had mentioned earlier that the Hadoop-based cybersecurity big data analytics platform that was built. So that sounds like something that was conceived in a cloud architecture from the start. Maybe you could talk a little bit more about what the decision processes were for how you chose the stack all the way from the programming language, even all the way down to the operating system.
So absolutely. Conceived as a cloud application from the start. Now, It, as I said, was an adoption of technology that NSA had already put into production, that a pilot had been accomplished in the Pacific to look at this technology in this cyber security environment. So really for us, we were able to leverage the investment that NSA had made in maturing open source technology in this domain, and it made for an easy investment decision. I think in general, if you look at how DISA operates, we are trying to minimize our investment of research and development funding. We have very little of that. Instead, what we want to do is leverage existing technology, even open source technology. We're not necessarily interested in building from scratch. What we want to do is partner with others in the federal government or commercial entities such as Red Hat. So Red Hat is one of the largest providers of Linux operating systems to the Department of Defense, and the reason is because we like the Linux operating system, we like the open source basis, but we're looking for professional support as opposed to having to hire an army of computer scientists to support a DISA unique build.
All right, on that note, we're going to take a short break. Our guests today are Charlie Bradley, the Technical Director for the NSA's Technology Directorate. Tracy Pavillard is the Executive Director at Dell Federal. Nathan Jones, Vice President for Federal at Red Hat. Dr. Naveem Venbar, he is the Cloud Engineer and Director of the GSA's IT Integrated Award Environment. And Dave Mihelsik, the Chief Technology Officer at the Defense Information Systems Agency. I'm your moderator, Tom Temin, on Open for Business, the State of Government Clouds, sponsored by Red Hat and Dell Federal on Federal News Radio 1500 AM and federalnewsradio.com.